These are problems, but can't get to it now. Okay. Now, I was hoping someone would be here for the main reason. I think I forgot to mark where we were beginning today. I believe we're starting at the beginning of 4.2. I don't recall that we did the first example, and I have a mark on the second example, but I think that was left over from the last time I taught the course. So I believe we're starting at 4.2. And if anyone is here, please let me know, because I can't see you yet. I don't have any indication you're here. So give me some sort of sign that you're here. All right, reduction in order. Remember how 4.1 finally ended last time by saying that before we actually start solving homogeneous and non-homogeneous linear differential equations, we need one additional bit of theory, which is presented in this section here, and that's called the reduction of order. All right, now in the preceding section, we saw, one we just finished last time, that the general solution of a homogeneous linear second order differential equation such as this, let me get my pen set up. Okay. A sub 2 of x, y double prime, plus a sub 1 of x, y prime, plus a sub 0 of x, y is equal to 0. All right. That's what we call a linear. Why linear? Because the only y terms you have in any term are your function y, your first derivative of y, and your second derivative of y. There's no other y terms or y prime terms in the same term with the y double prime. There's no y or y double prime term in the term with y prime, no y primes at all in the term with the y. And none of these are raised to any power except 1. Okay? That makes it a linear differential equation. What makes it homogeneous is equal to 0. Okay? What makes it second order? The maximum derivative is the second derivative. Now, what do these a's represent? Those are the coefficient functions, but they have to be functions of x and x alone. No other, no y variation in those functions. Not only that, well, in addition to that, the a's, the names, it doesn't matter what they are, the subscripts 0, 1, and 2 mean absolutely nothing except that this is the coefficient function that goes with the second derivative, this is the coefficient function that goes with the first derivative, that's the coefficient function that goes with the function itself, the 0th derivative, you might say. Okay. Now, we saw that the general solution for such a homogeneous linear second order differential equation such as this is going to be some linear combination. Y is equal to some C1, Y1, plus some C2, Y2. Okay? Why? It's a second order linear differential equation. It'll have two independent functions y with some arbitrary coefficients on it. This y1 and this y2 must satisfy that equation. The C1, C2 are completely arbitrary. They can vary as anything, any real number. Okay? Now, these are solutions. The y1 and y2 are solutions for that equation, like I just said, that constitute an linearly so we use the term linear a lot here, linearly independent set. We call it the, I'm going blank on the name, not standard, there is a name for it. we call that fundamental set. Fundamental set. Independent set on some interval I. Okay, that's an interval I. Now, beginning in the next section, we'll examine a method for determining those solutions when the coefficients first are constants. Okay, that method, straightforward exercise in algebra, breaks down in a few cases and yields only a single solution y of the differential equation. Turns out we can construct a second solution of a homogeneous differential equation even when the coefficients in the variable, okay, are all the coefficients of 1, provided that we know a non-trivial y1 solution of the differential equation. The basic idea described in this section is that equation 1, this equation right here, can be reduced to a linear first order this is a second. It can be reduced to a linear first order by means differential equation by means of a substitution. Okay. And that will involve the known solution involving y1, which is your known solution. So first, you've got to know that there is a solution that works. And if that's the only one that you can figure out, we can come up with the second one by this method we're going to talk about here. The second solution, y2, is apparent after that first order differential equation is solved. Okay, and this process is called reduction in order. You go from a second order down to a first order. So let's just suppose that y1 is a non-trivial solution of 1. Okay. On I, on that interval I. We're looking for a second. A y2. So that the set consisting of y1 and y2 is linearly independent on y, such that y1 and y2 linearly independent on that interval I. Now, back in section 4.1, that if y1 and y2 are independent, okay, if they are linearly independent, okay, then their quotient y2 over y1 is equal to u of x. These are both functions of x. Okay, or another way to express that is y2 of x is equal to y1 of x times u. It doesn't matter which order. They wrote u first, u of x. Okay. That function u of x can be found by substituting this value, this y2 value into the given differential equation, and that's called the reduction in order, because we must first we'll solve the first order differential equation to find that u. So here's the example 1. Okay, that was a lot of blah, blah, blah without very much that I consider very definitive. So you're going to learn how to do this. Oh, there's Vincent, right? Do you hear me yet? All right, got you. Have you? Okay, I always see everybody that pops up. Do you see if Keyston's here or not?
No, he's not here yet.
Not here yet, okay. I have so many different programs open, I usually only see 1 or 2 names. Usually can't see their pictures. Sometimes I can, but usually just the name. So I've only got yours. So welcome to the class. Before we get going back to where we left off just then, do you have any concerns that may have arisen since last week?
No,
okay, everything's going well then, huh? All right, good. Glad to hear that. What's that?
Is it MLA format?
It doesn't matter. You choose your format and just stick to it. Be consistent. Okay. Couple of kind of new things that have happened to me, perhaps since the last time we met. If you recall, and remember, the college is trying to do everything that we can to offer all the services that we could when we're on campus to offer them to our virtual campus as well. One of those involves advising. So they have opened a brand new, what they call virtual advising center, okay? And they are having us man that center. By us, administrators are doing it, but they decided since department chairs didn't have enough to do themselves that we needed to help them man the virtual advising center, not the regular faculty members, okay? So that means whereas I had a total of number of office hours, I had 2 hours on Monday and Wednesday mornings, I still have those 2. So those 4 hours are still okay. But I also had 2 hours on Monday afternoon from 3:45 till 6, actually 2 hours and 15 minutes, and then another 4 hours on Friday, 8 to 12. They have eaten up those 6 hours. So whereas I used to have 10 hours, only 10 hours a week of office hours, now I have 4, okay? So my number of office hours has shrunk dramatically, which means my time to grade papers has shrunk dramatically. That means my time to do anything, check emails, all that kind of stuff has shrunk by more than 50%. So I may be even slower, believe it or not, at answering emails and getting things graded, things posted on Blackboard. I'm going to do the best I can. At least this week we don't have as many meetings as we did last week, so it may be not much of a difference this week, but in subsequent weeks when I would love to be doing catching up on things, I'm not. I'm going to be advising. Now, they don't always fill every slot, so those half-hour slots that don't get filled, I can still be doing office hours in. But you can't tell when those are. I can barely tell. I've got a little calendar that shows a schedule sheet that shows who's calling when. So I will be stuck then. So, but you can't tell when I'm stuck and when I'm not. But give me a shot. If I don't answer, that means I'm probably advising. Okay. Any questions then? All right. We just covered the first half of page 132. We're in chapter 4, higher order differential equations. We just finished 4.1, which is a very, 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 very long section. Let me see. It went from page 118 to page 131. So that was about 14 pages, okay, of one section. We're in 4.2 now, which is a total of 1, 2, 3, less than 4 pages. So it shouldn't take us as long in 4.2. And what we're talking about is reduction in order. So here's the situation. You missed the first part. You can go back and read that. But here we have the situation. We're given that y1 is, which is e to the x. Okay? And that is a solution to this differential equation. Y double prime minus y is equal to 0. Okay? On the interval negative infinity, and my pen was doing so well, and now it started slowing down again. Okay? And not writing. Okay, from negative infinity to infinity. Now, first, pretty easy to show that is a solution, right? Because e to the x is y. The first derivative of that, y prime, would be e to the x. The second derivative would be e to the x. E to the x minus e to the x, sure enough, that's 0. So that is a solution everywhere on that interval, from minus infinity to positive infinity. Those are the values for x. Okay. But that's the only one we got. That's a solution, but we have a second order differential equation. That means there's another independent solution out there somewhere that we've got to determine. Okay? And here's how we do it. Okay? We're looking for a second solution, y2, that has to be linearly independent from that y1 and also a solution for that differential equation. So here's how we proceed. Let's assume that y2, and for some reason they dropped the subscript. Okay? I'm not sure why they do. Let's go on and drop it because they did. But to me, they should have kept it. Okay? But y is equal to some new function, u of x, that we have no idea what it is, times y1 of x. And my pen, okay, there it comes. Okay, well, because we know that the y1 is e to the x, this would be u of x times e to the x, because that's what our y1 is. Okay, now, what we're going to do is find, see if this new function here will solve that differential equation, second order differential equation. So what we've got to do is take the first derivative of it first, and that's going to be product rule. You tell me. Taking the derivative of that equation right there. Ux e to the x. No, just the derivative of e to the x is e to the x, right? Plus, so the product rule is the first times derivative of the second, which we just did, plus the second times derivative of the first. Well, we don't know what u of x is, but its derivative is u prime of x times the second, which is e to the x. Okay. All right. Now, we'll just leave that alone for right now. Now, the second thing they're dropping are the x's, the in parentheses x's. That'll make our writing a little easier. So let's do y double prime. Okay. Now you got two product rules now. One for the first term, one for the second term. So what would its derivative be? Say that again. Okay. E to the x for sure. What else? Wait, there's more. First times derivative of the second would be u e to the x. Now I'm going to shorten this. Okay. And now if you were doing a different order, the order doesn't matter here. U e to the x plus the derivative of the first times the second. The derivative of u would be u prime times the second is e to the x. Okay? Right? That's just the derivative of the first term. Of the second term, the first is u prime e to the x, because the derivative of the second term is e to the x, plus the first times the derivative of the second, second times the derivative of the first would be u double prime times e. Okay, so that's our second derivative. But look at here, these two terms are the same, so we can shorten this ever so slightly to be u e to the x plus 2 u prime e to the x plus u double prime e to the x. Okay? So there's your second derivative. Now, in this case, they're going to, okay, now we're going to plug in what we know here and here. This is y double prime, this is y. Plug that into our differential equation. So y double prime is u e to the x plus 2 u prime e to the x plus u double prime e to the x, okay, minus y. But y is e to the x, right? And that we know is supposed to equal 0. Okay. Now, at this point, finally, they say, wait a minute. This was a U. Sorry. I was looking up here. Should have been looking here. This is our Y right here. I left off the U. So let me erase and catch that up. I was looking too far up the page. This is what I should have put in there. Plus U e to the x, or minus u e to the x. That's your y, this y right here. And that's equal to 0 from here. All right, now what you get out of this is that this one and that one add to 0. And those are the two terms that had u's in it, just u, okay? So that means, I'm going to rearrange the order here, you get u double prime plus 2u prime times e to the x is equal to 0. All right? Now, to make a long story short, e to the x will never, ever, ever be 0. Do you remember? E to the x graphs, if I can get my pen to show up, like this. It's either going like this or it's going like that. One way or another, that's what e to the x is doing, depending on if x is positive or negative or whatever. Usually e to the x looks like that. It's never, ever, ever equal to 0. Okay? Why do I say that? Well, that means I can divide it out of this expression here. It's not equal to 0. I'm trying to get my eraser to come up, and I don't know where it went. There it went. Okay. All right. So, because it's never equal to 0, that means that the other term factor has to be 0. So this implies, since this is never equal to 0, that means that u double prime plus 2u prime has to equal 0. Okay, now that's supposed to be a 0. It's a pretty ugly one. All right. Now, since we lost our 0th order in our problem when these two went out, that means that we can change and let u prime equal some new variable w of x. Okay? And if that's true, then u double prime is equal to w prime of x. The derivative of u prime is u double prime, so the derivative of w is w prime. Okay? So our new equation here is w prime of x, if it would write, okay, plus 2w, I'm going to leave off the of x's, is equal to 0. Okay? It's supposed to be an x there. Okay. Well, that's a linear differential equation. Okay? So we just reduced the order from a second order differential equation to a first order. So if we can find the solution of that one, we'll be in good shape. Okay? Well, let's rewrite this again ever so slightly. This is dw dx plus 2w is equal to 0. Right? Guess what? That's separable. dw dx is equal to minus 2w. You just subtract 2w from both sides of the equation, right? Follow? And then we can divide both sides by minus, well, let's leave the minus 2 over there, and divide both sides by w, and multiply both sides by dw, or write that in differential form if you prefer to say it that way. I mean, not dw, dx, sorry. dx. That's ugly, isn't it? I can't get the pen to come up. I mean, the eraser to come up. There we go. Finally came up. All right. Okay. Those are dx's, not dw's. Okay. So these go out, and these go out. Yuck. This is so aggravating. So what we have now is, oh, we didn't divide this by w. That's where it left off. So we have dw over w is equal to minus 2 dx. Okay? Well, I can integrate that. That gives me log w is equal to minus 2 x plus some constant c, right? If you integrate both sides of this, it would be log w is equal to minus 2x plus c. I'm not going I think I'll write that as log c. Maybe even minus log c. Let me see which way they go with it. Yeah, let's make this a because the c is just a constant, and we can make it any constant we want to. I can't get my pen to come up again. There it comes. I mean my eraser. So let's make it minus c. Okay. We'll even make it a minus c1 to keep it like the book is. Okay. No, minus log of c1. Sorry. It's a horizontal eraser. So let's add it to the other side. So that would be log c1 plus log w is equal to minus 2x. Okay? And you can combine those two to be the log of C1 times W is equal to minus 2x. And now E both sides. E of this, and you get C1W is equal to e to the minus 2x. Yuck! Okay. Well, let's divide both sides by C1 and make that just a C, and you have, or maybe C2, W is equal to C2 e to the minus 2x. Well, guess what? That W we put in for our U prime. So let me make sure I'm on the same page now that they are. Okay, they went about it a slightly different way, which is okay. They went through the linear integrating factor, which works okay. But the W is equal to, I called it C2, they called it C1, e to the minus 2x. We got that. So let's now, here, that's what U prime is. So U prime is equal to, where was it? I'm calling it C2 e to the minus 2x. Okay, now let's go through the same routine again. Make this du, okay, dx, I'm going to write it in Leibniz notation. I'm going to try to, is equal to that. Multiply both sides by dx, if you think of it in that way. Okay, it just wipes it out. And then integrate both sides of this. And what we have here is u is equal to, I'm going to put the C2 out front. Yuck! It doesn't really matter. And then the antiderivative of that is minus 1/2 e to the minus 2x plus another, and I think they may call this is so frustrating, they call this their C2. I'm going to make it my C1 plus C1. I've just reversed the numbers on the things. They're just constants. They can be called anything you want to. Okay? So that's what we get there. Okay? But then we've still got another step to go. This u, if you remember, I may not have written it down. Yeah, there we go. This y up here is equal to that u, which is a minus, I think I'll go back to make it look like there. Change this and make that a C1, this a C2. They're just constants, you can do anything. Minus C1 over 2 e to the minus 2x plus C2 all that's your u from down here, and then multiply that by your e to the x, which was your known solution up here. We're close to the end if I can ever get my screen back. There we go. All right, then when you multiply those two together, e to the minus 2x times e to the x, that will equal minus c1 over 2 e to the minus x plus c2 e to the x. Okay. Now they do a sleight of hand here, and they just say, let's let C2 equal 0 and C1 equal minus 2. We obtain the desired solution of y sub 2 is equal to e to the minus x and they don't give any real reason for doing that. To me, this is a perfectly good form. I would just say, let's this be our new C1, okay? And then we have two linearly independent functions, e to the minus x, e to the x. One constant is C1, the other is C2, okay? I don't know why they do this equals 0, that's equal minus 2. That gives us a desired second solution. Who cares what the desired second solution is? I guess what they're saying, we already have the e to the x in it, so let's just let c be 0. Okay, fine. And then just to make it look better, let's just have c1 be a minus 2, and then that becomes just 1. So we have our two linearly independent solutions, e to the x and e to the minus x. And if you'd left the c's in there, those would have been your arbitrary coefficients. So I don't know why they took them out, and then what they'll do is turn around and put them back in if they wanted to. Now, kind of frustrating trying to figure out why they randomly do some of the things they do. Have you got this, or I need to leave it a little longer? Oh, man. Oh, there it goes. You okay, Vince? Vincent? You still there? Okay, I hope you are. You're on mute, so I can't hear you. Anyway, I'm going to clear the screen because I can't get an answer from you. Okay. Now, here's the general case. I'm trying to find, oh, okay. If you go back to what we talked about at the very top of the first page, 132, here was our general form, a sub 2 of x, y double prime, plus a sub 1 of x, y prime, plus a sub 0 as a function of x times y is equal to 0. A linear, homogeneous, second order differential equation. Okay. So what we're going to do, and this goes right back to what we did way early when we did linear equations in chapter 3 or 2 or whatever it was, let's divide everything on both sides by a sub 2 of x. By the way, that can't be 0 for any value of x in the domain, because in the interval, this is on some interval, I. It can't be, because if it was, that wouldn't be a second order differential equation. It'd be a first order. So the a of x can't be 0 anywhere, so it's a legal thing to divide everything by a2 of x. a2 of x. When you divide a0 by a2, divide 0 by a2 of x, you still get 0. Okay? So this goes to 1. So our new form is now y double prime plus, now, this is just some function of x. It may be a rational function of x. Fine, no problem there. It's a function of x, and they're going to call this, just like they did before, p of x. and that's times y prime. And then let's call this ratio q of x. And that's also could be a rational function, that's fine, times y, and that's equal to 0, where p of x and q of x are continuous on some interval I. They need to be continuous on I, just like where our differential equation was continuous, because for this, everything now is the same. Okay. Let's suppose even further that y1 is a known solution of that equation. We're going to call this 3 now. It's a known equation of 3. Okay. So y1 is a solution. A solution of 3. Okay. That's awfully ugly because the pen's not writing all the things I write down with it. It's a known solution of 3. Okay. On this interval I. Okay. And that y1 of x is not equal to 0. Now, for every x in the interval, in that interval I, okay, for all those x's. Now that's something a little bit new, but in other words, it's a non-trivial solution, okay, anywhere, okay. Now, let's come up with that new variable, y, just like we did before. I don't know why the pen's not writing. Y is equal to u times y1, just like we were doing in that last problem, okay? And we'll do just like we did before, that y prime would then do, by the product rule, u times y1 prime plus u prime times y1. Product rule, right? Following? I hope so. I thought I heard a little noise there. Let's go on the next step and do y double prime. My pen's not writing and it's so aggravating. Okay. Y double prime. Okay. Will then be take a derivative again, and this would be u y1 double prime plus u y prime. U prime y1 prime. Okay, u prime times y1 prime plus u prime times y1 prime, that's the first time derivative of the second of this one, plus u times y1 double prime. Now I may have gotten the order out, but it's okay. And this comes out being u y1 double prime. No, I'm sorry. This is a u double prime y1. Okay, sorry, I got carried away there. The product rule for this one, let me get my pen back because I don't want to erase something I don't want to erase. Okay, the product rule for the first one is u y double prime, y1 double prime, plus u prime, y1 prime. Product rule for this one is u prime, y1 prime, plus u double prime, y1. Okay? So this gives us a u y1 double prime plus 2 u prime y1 prime plus u double prime y1. I don't know why it does this just about every time. Okay, so that's our y double prime. So we're going to take this one and plug it in here. So this is going to be u y1 double prime plus 2u prime y1 prime plus u double prime y1. That's the y double prime term right here. Okay, plus p of x times y prime. Well, the y prime is right here, and that's going to be u y1 prime plus u prime y1. Okay? Plus q of x okay? Q of x, that's a plus, the pen's not writing well at all, times y, and y is simply u y1. Okay, so I'm going to leave off the and x's. And we know that all that has to equal 0. Now, remember we said that y1 is a solution of this equation right here. y1 is a solution. So let's pull that out. Okay? Let's take this term here, u times y1 double prime. Okay? And then we're going to add to it this term here, the p of x times this. That's going to be plus p of x u, I already pulled the u out, sorry about that. y1 prime, okay? And we'll also pull out this one, which is plus q of x. I already pulled the u out, y1. Okay? Now, I pulled this term, and this term out. The ones with the u in it, pulled the u on the outside. Okay, what do I have left? Plus 2u prime y1 prime plus u double prime y1 sorry, it goes away and then I have to get it back. Okay, plus p of x times u, I'm sorry, I say u on the right line, u prime y1, and that's all. This whole thing is equal to 0. Okay. Now, but if you remember, y1 is the solution of this. So that means y1, put it in there, that's equal to 0. Well, that's exactly what this is. So this is equal to 0. So what do we have now? We have, I'm going to start with my u double prime. U double prime plus 2y1 prime plus p of x y1. All this is time u prime. and that's equal to 0. Okay. Now let's make sure I'm on the same place that they are. Well, I can't see anything because the screen disappeared. So U double prime, I've left off my Y1 here. Okay, sorry about that. Okay, U double prime Y1, they write Y1 U double prime, doesn't matter, plus 2Y1 prime plus P Y1 times U prime is equal to 0. Okay. Now, we're going to do the same thing we did on the last problem. Since we lost the U terms here, they all went away because this thing was 0. Let's go with a new function. W is equal to U prime, meaning W prime is equal to U double prime. Okay, and now we'll plug that in. W prime Y1 plus 2 times Y1 prime plus P Y1 times W is equal to 0. Okay. Now, that is a linear and separable equation. Okay? It's kind of a mess, but it is a linear and separable equation. And I don't have room to do it now. So what I'm going to do, I'm just measuring what I need to keep and what I can throw away. I think I can keep, I can eliminate all this because I'm not using the A's anymore whatsoever. So that's out of here, which is kind of good because I need the space. Okay. Now, do I need that additional differential equation? It sort of seems like I would. I don't know that I do, but let's see what we can do with this. Okay? Now what we're going to do, I'm going to rewrite this equation a lot like what we did before. I'm going to write that W prime as dW dx times y1 plus 2y1 prime plus p y1 times w is equal to 0. Okay, now that's a w, it looks like a u. Pen just isn't writing it all well. Okay. Now, let's get all the terms with the w's by them. Well, let's first do this. dw dx times y1 is equal to minus 2y1 prime plus p y1 times w. Okay, I'll just move that to the other side. Now, let's divide by w, multiply by dx, basically. Okay? Write it in differential form if you like that better. This gives you dw over w That's what you get by dividing both sides here by W. Okay? And we already got rid of this by putting the dx on the other side. Okay? Okay. And this is equal, and this is times y1 is equal to, these are all x terms here, a minus two y1 prime plus p y1 dx. Okay. And I don't know what to do with the y1s here. They divided them. Okay. They also divided out the y1s. So this will be over y1. This will wipe out the y1. Okay. So this will be over y1. This will be y1. And this wipes out the y1. Okay. Now, let me erase this next line down here. I know this is really scattered. I'll leave that differential equation there because it just feels like you're going to need it again. I'll wipe this out too. Oh, we just used that fact when we said that y1 can't ever be 0 because we just divided by it. Okay, so that gave us credence. If I just wipe that expression out. Okay, this is taking way too long. Okay. So just a summary of what we've got then. Is this. Let me go back in and pick it up here. I'm going to rewrite this up here as dw over w is equal to 2y, and it should be a minus. Oh, no, they've moved it back to the other side. So rather than equal to, they're putting it plus. Can't quite figure that out yet. I mean, why, but it's a legal move. I just don't know why they did it. Okay. I cannot get... Okay. So I'm trying to get my eraser. It's been hard to get it today, and there it is. Okay, we'll change this to a plus, as I'm adding that back to the side, plus 2y1 prime over y1 plus p, well, yeah, it's going to be a plus because we moved it to the other side, p dx is equal to 0. Now, that's what I'm getting. Let me make sure that's the same thing they get. Yeah. Now they put the dx in each term. That's okay too. So when you integrate this, you go back to your linear equation form, okay? And this is just taking way too long. if you went back to that original form, now you'll have to just go look this up because it's all there. The integrating factor is now no, not quite. What we're going to do is integrate both sides. They're going to put the dx in here, okay? Now, and take off your parentheses. Supposedly that makes it look a little better or something. I don't know exactly why they keep bouncing back and forth. But this, you know, is a log W, okay, plus. Now, what we have here is a y prime over y. And you're trying to integrate that. Okay, when you integrate this, you get that. When you integrate this, and then we'll integrate this. Okay. Now, I don't know if you remember this. But they just skip all over lots of things here. Let's come over here for a moment. And what if you had 1 over y squared? Is that it? Yeah, which is, I think this works, y to the minus 2. And you are integrating that. Okay? No, taking a derivative of this. Taking a derivative of this. So, derivative of this thing, okay, would be excuse me. That would be a minus 2y dy dx, right? Sorry. Which would be, I may have done it the wrong way. Let me start over. Well, I just don't want to take so much time. We're already running short of time. All right, let's try something else. I may have had it right that time, but it just didn't feel like it was coming out quite right. Let's take y squared. Okay, d of y squared dx would be 2y dy dx. I'm not sure. I think I was right the first time. That still doesn't have it right. I think I just made a silly error. Okay. Okay. I was getting too fast. d by dx of y to the minus 2. That would be minus 2 times y to the minus 1 dy dx. That's it. Okay, I think. Okay, which would be minus 2 y prime over y. Because y to the minus 1 is 1 over y. I don't know why it won't write, but it's down there. This is so aggravating. Okay. Okay. Now, what we have in this term here is exactly that. Okay? The integral of that, only it's got a minus there. And that is exactly derivative of this, or minus the derivative of that. So this would be a minus, where is my pen? Okay, so this will be a minus, and if the derivative of that is that, then the integral of this thing would be that, y to the minus 2. Okay. Without going any further, let's just jump to the bottom line. Now, I think we just need it on a piece of paper, on clean paper here. So let's just go to clean paper. Okay. What it ultimately gets down to, that log that we had before, you can now combine that y squared, 1 over y1 squared that we had before here, and you get log of absolute value of that w we had times y1 squared, which we had 1 over y1 squared there. That's on the left-hand side, and this is equal to minus the integral of p dx, okay, plus c. Okay? Now, what you have from this, if you take the e of both sides, okay, this will wipe that out. You get w y1 squared is equal to e to the minus integral p dx. And you can take that plus c and make it a constant in front. I mean, skipping a lot of steps just like they do. But, just make this a e to the c, and then, yeah, that's indeed what you've done, e to the c, and move that in front. Now, that w, and this is why I regret erasing, remember the w was u prime, so if you did that, skipping too many steps. I hate it when they do this, but we just don't have time to pick them all up here because we're running out of time. And remembering that w is equal to u prime, okay, which is du dx. So writing that in for w here, du dx, multiplying through by dx and integrating, you wind up with u is equal to some c1, came out of nowhere it seems like, the integral. Now this y1 squared we're going to pull into the denominator, okay? In fact, we do that before when we do this thing. We divide this by y1 squared. So this will be the integral of e to the minus integral of p dx, okay, divided by this y1 squared. Okay, now that's everything that you had there, and this is a dx from that integral you just did here when you integrated here to get integrating your du dx. And then you get a plus c2 here. The c1 from the first term and c2 from there. And again, they pull this deal of choosing c1 equal 1 and c2 equals 0, so you don't have to worry with it. Here is your second substitution. y2 is equal to the new function y2 is equal to y1, and this is a function of x. y2 is 2, but why they put it in here, I don't know. Times the integral of e to the minus the integral, I can't get my integral, there it is, p of x dx divided by y1 squared dx. Now, that's what your new function is. Now, this isn't worth memorizing. They say that every time. It makes a good review of differentiation to verify that, and that they're linearly independent, okay? And that's all they say. But that's the bottom line. There is your new y2. Now, that looks incredibly complicated. Number one, you have to remember way back what your p of x was. That was the ratio of your original a1 of x divided by a2 of x, okay? But it's not that bad to deal with. Now, we got 3 minutes, and I want to see if we can do example 2 in those 3 minutes. I don't know that we can. I've been wanting to get there, and let's see if we can. Remember that last equation, okay? We'll pick it up in a minute here. So here's a function. y1 is equal to x squared, okay? And they say it is a solution of this differential equation. X squared y double prime minus 3x y prime plus 4y equals 0. Frankly, I'm not sure we're going to get it. This is a little bit more involved equation than I thought, okay? And it said, find the general solution of the differential equation on the interval, and this is going to be from 0 to infinity. That leads me to think there's going to be a log involved, and I bet there is, okay? Now, they say it's the solution. Of course, my first reaction is, let's verify. So this would be y double prime, okay, y prime is equal to 2x, and y1 double prime is equal to 2, okay? So this would give us 2x squared minus 3x times 2x is minus 6x squared, plug that in, plus 4 times x squared, okay? Is that equal to 0? Sure enough it is. 2x squared plus 4x squared is 6x squared. 6x squared minus 6x squared is 0. Okay, so indeed that is a solution. Okay, so that wasn't necessary to do, but I never want to trust them if there's a chance they wrote something wrong and we're going to try to do something that is impossible to do. Okay, and it would be if we assumed that was a solution and it wasn't. Okay, we got half a minute. Okay, so I think we're going to have to pick up from there next time. I had wanted to get there. We're going to find the solution based on the equation 5 just above here. So this is where we're going to pick up next time. We did not make great progress today. I was hoping we would, but that general case is a real bear to prove, okay? And I wound up just skipping over some of the proof. Homework exercises here. I think you can do some of the odds 1 through 15. Give them a shot anyway. We'll pick up the rest of those next time. Only if they're in the back of the book, try to do those. Okay. Any questions? I know that went awfully fast and furious and awkwardly, but it went. Any question?
I'm gonna have to rewatch. I have some connection issues.
Okay, I can't hear well. Say again.
I said I'm gonna have to watch it on YouTube. I was having connection issues, so
Okay.
I kind of missed some.
Okay.
Some
Well,
I'm gonna rewatch it, and then
okay. If you can have a book handy, that would be helpful too, because I had to back up and go several different directions on a couple of those problems. So have the book handy so you can watch. All right, we are out of time. We'll see you on Wednesday, right?
All right, thank you.
All right, good deal. See you then. Bye-bye. I'm ending the meeting now. Hello, is this Victoria? Yes, this is Charles Fowler. Yes, yeah. Is the phone okay? Dr. Dave, okay, okay. Dr. Davis said all of her people this morning wanted that, so um, yeah, okay. I think I've got you here now. I was trying to find you on the email as well. Actually, they told us to do it from the other thing, but Dr. Davis sent us an email this morning, said all our students preferred uh, the phone. So I went, fine, I'll do the phone. Um, let's see. I want to make sure I've got you. Okay, now that's the problem. Okay, it's 4 o'clock Monday. Oh, I'm looking at the wrong Monday. That's okay. Sorry about that. Uh, yeah, yeah, I know. 13th or you're today, right? The 4th, 6th. Yeah. Okay. Okay. All right. Super. Okay. Let me see if I can find you on the other though. All I saw was the 4 o'clock. Okay. New appointment. That's 6 o'clock. Okay. Okay. Fine. And let's see. Did did you say the same thing for 6 that you did for 4? Okay. I'll pull that up because it's handy. I saw it first. This is my first time, so I'm still learning this thing. Okay. Okay. All, okay. Okay. I've already got that I have somebody else in 6 p.m. anyway, so let me view my calendar and see if that will help. That may be much quicker. Okay. My computer is not very quick though, so it's taking time. For in the meantime, what is it? Some of the things you needed? Oh, okay. Uh-huh. Okay. Um, had you been working with Miss Johnson in the VA office? Boy, I mean, I don't know what I said. It's Miss Williams. It's Sharon Williams, but there's two S. Williams, and I can't remember what her middle initial is. It seems like it might be D. But if you go to the Lawson State webpage um, and look under directory and do financial services or financial aid or something like that, you'll see the thing. Click on that. It's a go that you press, and then you'll have to scroll down a little bit, and you'll see a whole bunch of people there. Sharon Williams is she's the guru when it comes to uh, VA stuff. Oh, okay, yeah. I imagine things are pretty busy right now, so but she'll get back to you. They're doing, and actually, I think there's an overall place, and I just don't remember the name of it. It may be Financial Services at lawsonstate.edu, and they may even have one specifically for the VA, but I don't know that for a fact. I know. I found it's not a very convenient website at all. I have trouble, and I just go to the places I know to go, and the rest of it I don't even mess with. But yeah, for someone new, that I can see how that is overwhelming, or it would be for me. Okay. My computer's so slow, but finally it did come up. Okay. It's not your 6 o'clock, that's somebody else's. Goodness, they only show that I have one. There's got to be something wrong with this. That took me to somebody else. So let me get out of this. Calendar. Let me go to check calendar. There we are. Okay. Let me go to the bottom. Well, it won't take me to the bottom. Finally, Victoria Phillips. I see you now. We're well on the way, so let's see if we can pull this one up. Okay. I've got a very slow computer. It's just running in circles. Okay, here you are. All right. It says here, hi, Dr. Fowler. This is Victoria. It's Victoria Phillips. I met you this spring on your birthday, and you helped me sign up for classes I will need for vet school. I've finally got my VA scholarship from the state. I'm ready to start, just what you just told me. Okay, so what do you need today? How can I help here? Okay, my hearing is bad and I didn't have a pencil ready. What did you say? You'd like to sign up for what? Okay, is that the 201? 201, not the one based on calculus. Okay, Physics 201. Okay. You remember what the title was? Okay. Right. 111. Okay, so you want to try to do 111 this summer too? Okay. So yeah. That would be 8 hours with those two courses. Anything else? Yeah. Yeah, and I think the 112 is a prerequisite for that. Now, are you a Lawson student or are you a transient student? Okay, so you are actually registering as Lawson. You're not coming from another university and taking summer classes here only. Lawson, okay, yeah. So yeah, we wouldn't be able to do your organic. If you're coming from another school, we'll put down whatever they say they approve. But if you're with us, then we have to do it according to the prerequisites. And so you wouldn't be able to take organic until you finish 112, chemistry 112. Okay? Okay, so physics 201 and chemistry 111. Anything else? Okay, biology 103. Oh, okay, the second course in it. Okay. You've already had the 103. Okay. And biology 104, the way we teach it is mostly non-human. So that would be all the other plants, animals, and everything else other than humans, because we teach our biology 103 as human biology, and then everything else is 104. So, okay. So that gives you 12 hours right there. Those all 3 science courses, all 3 have labs. So that would be 12 hours. Do you want anything else? The 103, 104 sequence is for the science people. The 101, 102 sequence is for the non-science majors and non-medical majors, right? And which did you have in your first course? The principles or 103? Yeah, okay, so it's good to go with 104 then. Okay. Wow. Okay. Are you sure? You sure you want to do 12 hours here plus courses there? Okay. Right. Okay, now, did you say Chem 111 or 112? Okay, I wrote down 111. I misunderstood. So you've already taken Chem 111, right? Oh, you want to retake Chem 111. So I had it correct. Okay, got it. Okay, so you want Physics 201, Chem 111, but Biology 104. Okay, and then whatever else you're taking at Jeff State. Is that right? Okay, so do you need me? Okay, now are you counted as a Jeff State student or a Lawson student or both? Yeah, you're going to be both. Okay, so what is it? Do you need me to? Okay, let me see. You want me to try to register you for those? You see, usually when you called on my birthday, I was in my office at work and I could do it on what the basic system. Now we're on a faculty suite, which is not nearly as easy to do. Let me log in. Or can you do it? Yeah. You still what? My hearing's bad. I missed that part. You. Oh. Okay. So am I your advisor? Okay. Well, let me find. Okay. I don't have your name on the screen anymore. Okay. Oh, maybe better is give me your student number. That might be easier. Okay, let me see if I can get this right. 144. That sounds a bit high. Okay, 276. Okay, now we have 7-digit numbers. Okay, well then let me go back and do name. Go back to that one. Okay. And last name was Phillips. Is what? With 2 L's, okay. My hearing's so terrible. IPS. Okay, let me just see if I can get you with that. You know, I'm not showing it. So let me get non-advisee, just in case I'm not your advisor. Okay. Oh, I don't have those. Okay, Phillips. Try this again. Phillips. And we'll try a go on that one and see if I can find you. Whoa, student number required. Yuck. But you don't know that. That wouldn't have a 2 in it, would it? 1244, blah, blah, blah. Okay, 1, 2, go through that number again. Wait, okay, it's not typing. 1, 2, right. 276. Let's try that one. Nope, that's Tristan Devon Wall's plumbing major. Okay, that's not you. Oh, yeah. Let me try 1242238. Does that sound like it could possibly be it? No, okay. Okay. All right. So what we might need to do, have you reapplied? Okay. Okay. Well, I tried doing your name, Phillips, and it won't do it without a number. Let's see if it'll take that. Let me see, schedule inquiry. I wonder if, let me try this. This is sort of sneaking. Spring. You were originally scheduled for spring. Okay. You remember one of the courses? Okay, Physics 201, but you want this time 20. Oh yeah, Physics 2. Okay, got it. PHY 201. And instructor was Bryant, right? Okay. Okay. Oh, yeah. Let's see. Let's see. Let me just try go here and see what happens. Okay, here we are. All right, let me see if I can find people registered. Okay, but you were dropped. I think all it's going to show are those that are totally registered, so that's not going to work. Yeah. Let me see, what else can I try here? Yeah, the green screen, yeah, the old system. Okay. Let's see. That didn't give me anything, so I want to go back to something else. Back. Okay. Let's see, what else can I try here? See, I wonder if degree plans will let me choose a social security number. Let me try that. Oh no, I sure don't want it to do that. cancel that. It said print all the plans. I don't want that. Okay. Yuck, it just got me out of everything. Okay. So it sounds like to me that we need to talk with someone in admissions. And yeah. And what you do is, okay, were you able to find on Lawson State webpage the directory? Okay. Okay. You don't have a computer or anything you can see if I walk you through how to get there. Yeah, that may do. Did you see an option for that? Okay. And are they going to come back with a time for you? Oh, you've already done that in the past. I thought you just did it just now. Oh, I see. Okay. Okay. Yeah. All right. You might also see Miss Williams to see if she has your file, and she might be able to get to it quicker. Were you ever able to get in touch with her? Okay, let me, I'm going to go to Lawson State webpage now. I'm going to try to go there. My computer is so slow, it's walking there. Okay. When you go to the Lawson State webpage, at the very top of the page, there's a bunch of blue tabs there. And the fourth one over says directory. Okay, I'm going to click on that. And then it has last name. That shows up. So I'm going to put Williams. And first name is Sharon. If I can find the key. Okay, and then hit go by any department, because it'll take you right to, by the way, okay, okay. And then you scroll down, and there it is. William Sharon Financial Aid. There's a phone number, but that's the on-campus phone number. That won't, unless she has it forwarded to go home, that wouldn't do. But then on the fifth column, you see email, send message. That should get it to her. Okay? Oh, you have? Okay, I'm sorry. I'm afraid so, possibly. Yeah, when you get the information, especially your ID number. Okay, if you can get that ID number, we can make sure you are registered for this term. Be sure you get your ID number and make sure they've got you down for registered for this term. I mean, not registered, but enrolled in this term. If they don't, that's what they need to do. And then once they've got you enrolled, then we can pick it up and go from there. Now, if you're already enrolled, then your ID number will be enough. But if you're not enrolled, do whatever it takes to get you, whatever they call that, registered. Well, not registered means you got in the classes. I'm trying to think of the right word. Accepted, or yeah, exactly. And yeah, if you can get that far, then I think we'll be better off for going from there. Okay? Because I can't think how else to go today without having the system in front of me. And this one, I can't find a way to do it with Social Security. If I ever find that out, then when you call back, I'll say, hey, I found out how to do that. But so far, I haven't found one of the keys that will ask for a social. They all ask for ID number. One of the Windows shop. Oh, you had tried it. Uh-huh. Okay. Right. Oh, that is really getting everything slowed down and stuff. So yeah, if you can get that done and find out you are in the system, then we can probably go from there. All righty. All right. Thank you. Sorry that we couldn't get any further. All right. Bye-bye. Hi, this is Charles Fowler. I think we have an appointment, advising appointment for Lawson State. All right. I'm in the process of trying to find you in my system. You're my second student, and I have to get out of the first one and find you in the second one. I have a new appointment. Let's see. And you're Kathleen, so let me see if I can find where that is. Okay. I have somebody whose appointment is at 6 o'clock tonight. I need to go to. Okay, let me. It should be, but I'm slow. Yeah. Okay. Said I have a new appointment. Say again? Okay. How do I get out of this one without changing it? The only thing they have is edit appointment. I don't think that I want to do that. Let's see what it says. Maybe it means change appointment. That's a dumb way to say edit. But all right, I think this may be what I needed to do. Okay. All right, let's go to calendar. That should do it. Okay. Okay. Kathleen Count, there you are. Yeah, and I'm a dinosaur, so it takes me a long time. Okay, so what I've got here, it says looking to register for Biology 201 with Miss Ellison. You got the course number. That's great. That will be your last prerequisite course for the MLT program at Jeff State. What is MLT? Oh, fantastic. Okay, good. Yeah. Okay. Okay. So you need help registering it. Is that it? Okay. 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 All right. So let me, you know your ID number? Okay. Don't give it to me yet in a minute. And can you hang on to that course number? 01820. You got that? Okay. So what I'm going to go to the faculty suite and log in, and this system is not quite as slow as I am, but it's awfully slow. Okay. Oops. No. Well, that didn't work. I don't know. Ah, it worked that time. Okay. Advisor Info Center. Okay, now am I your advisor or is someone else? Or do you know? Oh, she is your advisor also. You want her? Okay, so I'll have to add a non-advisee. Okay, I'll need the ID number then. Okay, I'll go with that one. Got you, Kathleen Count. Got it. Now, okay, and it says you're authorized to register online, so I don't know why that you don't have any hold. So let's see, can I register you from here? Let's see. Registration. I think that's probably what we want to do. Okay. Let's try that. Okay, summer term, student number, got your name. The only option it has is to cancel. I don't want to do that. So let's see. Okay, possibly. Had you emailed anyone or something like that? Okay, well, you try it. You see if you can get on and do it. Oh, you can't if we're on the phone. Okay. I thought maybe you're doing phone and computer. Let's see what these. Okay. All right, because that one said you were authorized, so you should be able to go. So, all right. You want to just try it on your own then? Okay. Yeah. Yeah. Try records at lawsonstate.edu if you want to do an email. If you have a help number, that might be good too. But I think records should be able to give it to you, and they might be able to tell you what is hanging you up. I've got the select student. I've got that, but it's not giving me anything I can do with that. Let me see what this does. Nope, that lost you. Okay. Registrations. Yeah, I would sure hope not, because that's just going to gum up the system badly. These, I think, are all your previous drops. Pre-register. Let's see what that will do. Okay. This is spring. Okay. Yeah. And that's what I had before, and that didn't get me anything. So what I'm going to do is try to go back. Okay. Actions or add drops. That just listed all those. Degree plan, you know that. Flag at risk, blah, blah. FA summary, I have no idea what that is. Registration, that would seem like that would be the one. Schedule, I think it's just going to tell me your current schedule. I think. Let me just look and see what that says. Is that this spring? Yeah. Chemistry 104. Is that all you took this spring? Okay, so that was this one. So I'm going to cancel that. It would seem like registration should be it. Now I click on that and it selects student. I have all this, but it doesn't say what to do. Let me click here and see what happens. Nope, that's not it. Okay. Okay. I don't know. I just clicked on some box that was up here, and all it says is no. That's trying to print something. Let me see what this one does. Oh, that just opened up the screen, but still. Oh, here's a go. Here we go. All right. Quick course call number. Go on and give it to me. 018. Is that right? What was the last? 20? Okay, that's what my memory was, but I didn't want to risk on it. Well, all the biology start with 018. That was the easy part. All I had to do was the second part. Okay. I'll put Miss Ellison down as the instructor. Whoa, went right back. There she is. Okay. And biology. And course 201. Got it. And let's do a go. All right. She's offering two of those. One is they're both virtual classes, you know, meaning that you meet at the time. Yeah, okay, you understand that. One of them is, where do they give that? Ah, here we go. Tuesday, Thursday. Now that's interesting. Both of these are listed as Monday, Wednesdays. And the call numbers are 1822 and 1842. It really is. Where did you get yours? Off the summer schedule? Right. All right, let me do search for course and see what comes up. Just gives me that. And we already went through that. So department will be biology. Yeah, here's the thing, and this may be what happened, okay? Because was yours fairly recent or it was a little while back? Oh, wait, okay. Give me that number. No, yours is 20. Okay. Last Saturday? Like this past Saturday, 2 days ago. Okay. Here's what my guess has happened here. You see, when we did the schedules back January, February, March, sometime early, like January, February, we were, of course, assuming we'd be on Bessemer or Birmingham. You know, we made up schedules that way. Well, then when all this happened, we no longer have campuses. We have one big virtual campus, okay? And what they did, if a course was being offered on the Birmingham campus and Bessemer campus at just about the same times, they probably just combined them into one class. But both of these happen to be Monday, Wednesdays. Neither one of them are Tuesday, Thursdays. But maybe adapting the other. Let me just see what they've got here for 201. If there's anything on Tuesday, Thursday. Here's a Monday, Wednesday. There's another that's online. Okay. if you want Miss Ellison, yeah, if you want Miss Ellison, here are her 2 times. Monday, Wednesday, 8:30 in the morning, and it'll be followed by the lab. No, yeah, that's a virtual class, and the other one is a Monday, Wednesday, 1:30 to 3:45. So which of those would you prefer? 1:30, okay. I will add that to your thing. All right. And say that again. Oh, okay. Yeah, I understand now. All right. Okay. Let's see. I don't see where it added it. Okay. We were just here. I didn't give you that call number, did I? Okay. B-I-O, capitalize them. B-I-O 201. What's that? Okay, I can't answer that for biology. I know how I'm doing it in physics, in physical science. I'm teaching a physics class without a lab and a physical science with a lab. Another instructor used these virtual lab simulators, and that's what I'm using for that. Okay. I thought I just added the course. Let me see what happens if I click it down here. Nothing. Okay, search for course. Let me try this again. Been here, done that, and bought a t-shirt. Okay. Okay, go. And there are the 4 sections that are offered, and you wanted the 1:30 to 3:45. Okay. Monday, Wednesday, 1:30 to 3:45. And I went to add the course. Okay, you're already in it, so I just can't, it doesn't show anywhere that you are. So I think you must be there. All right, and okay, and all right, glad to. I hope I did it well and didn't get you in there twice. Okay, 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 you can just drop one of them. Okay, all right, surely glad to. Bye bye. It's 5 o'clock. Not yet. Why does it keep coming back to that one? Oh my goodness gracious. Hello, is this Mr. Christopher Charleston? This is Charles Fowler. I'm an advisor at Lawson State Community College. I think you had scheduled an appointment with me right now. Okay. How can I help you? Yeah, okay. Right. Okay. Um, okay, you were asking, okay, what I see in front of me, it says my goal is to apply for dental assistant school during the summer. However, I do not see the Math 098 class offered as a mini-term during this summer. Will this class be offered as a mini-term? Is that your question? Okay. The answer is no, because the summer term is already a 10-week term. A mini term would be 5 weeks, and a math course in 5 weeks, especially developmental math course, would be, I would think, incredibly difficult to accomplish. So we don't offer those for a mini term class in the summertime. Now, you see, in a regular term, full-term class is 16 weeks, so a mini-term is 8 weeks. So the whole summer term is just a little bit longer than a regular term mini-term. So it's already almost like a mini-term course. So no, but we don't offer a 5-week course. Is that what you were asking? Okay. So any of the 098s that you see out there are the full summer term. Now, I can't right now say it's going to be a full 10-week term because we are supposed to be changing to a new system of, registering and everything else starting in fall term. And what they've told us now is that we have to have the grades in on the old system after 8 weeks, which would be almost like a mini-term course, but it's still scheduled for a 10-week term. If we can squeeze the next 2 weeks in, we're going to do it. But if they don't let us do that, if they say, no, you have to have your grades in at the end of 8 weeks, we're just going to cover as much as we can in those 8 weeks and hopefully have you ready for Math 100. Or whatever you do next. What is the next course you take for the dental assisting? Do you need Math 100 or some other math, or is 098 all you need? Right. Yeah. Is that why you're wanting to take it mini term, so you can knock them both out in the summer? Okay. Yeah. Okay. Yeah, now if it says June 27th, that is because they're making us end them 2 weeks early just because of that new system that's going into play. And so I didn't know they put that on the system yet. So what we're going to do is cram. That is a full week term, but we're going to have to cram a 10-week course into 8 weeks. So it's already going to be bad. You don't want it on a 5-week term. So yeah, those that are listed there, that's what we're offering this summer. And you have a lot of options to take them. Various instructors. There's only one campus. It's the virtual campus because we're not Bessemer or Birmingham this summer. Okay. So were you going to register yourself, online registration, or did you need help with that? Oh, you already did it? Okay, great. Okay. Here's a thing I noticed here. I don't know exactly what this means, but because I'm brand new, this is my first day doing this, and I've not seen these things before today. Well, I mean, I did during training, but that was all made up. here it says history. I don't know what this means. It says academic advising dash mathematics and engineering parentheses regular. Did you start off in mathematics and engineering, or have you always been planning to do dental assisting? Okay. Yeah, right. Okay, who was your advisor? See, okay. No, okay, yeah. What was her area? Was it dental assisting or something else? Oh, I see. Pre-nursing. Okay, right. Let me see if I can find any more information about you on that. I've just got this one page up here, and that's all it says. So you were in pre-nursing, not in, or that's what your advisor was originally. So what you need to do is, do you like emailing, or you want to do it some other way? Okay. There is a email number, and you can, address. It's just records with the S, RECORDS at lawsonstate.edu. That's a new email address they've got because of the virtual campus thing. If you email them at that thing, it'll go to several people, and someone will take care of you. Say that you were pre-nursing, but tell them the guy who you talked with on the phone says you're listed as mathematics and engineering, but you want to be dental assisting. So I think what they will do is change your degree to dental assisting. And when you do that, then you'll probably get a new advisor. And that's going to be Dr. Oh my goodness, I can't remember her name. I know her so well. She's one of my favorite people, but I can't remember her last name. I'm old and decrepit in mind. So, but they'll give you a new advisor, and that will be for dental assisting. And that way, all the classes you have will show up exactly what you need to take, when you need to take it. And that way, too, I don't know if you're on financial aid or not, but financial aid will cover things. Now, there's no problem with this 098 course. That's covered in any major. So that's okay. But when you need to be in the right major when you start applying for classes in that major. So what you need to do is do that, send an email to records@lawsonstate.edu and ask them to change your major from whatever it is to dental assisting. And I think they'll probably be able to take care of that. And if they do need any more information, they can email you back or whatever. But I think, that would certainly help you. It's not going to make any difference for the summer, but it will help you when you're trying to do your major courses, because then you're going to run into difficulty if you're listed in one major and you're really in something else. So, yeah, if you can do that. So is there anything else I can help you with today? Oh, that's it. Okay. Well, that's, you were an easy one. Thank you so much. All right. All right. You too. Thank you much. Bye-bye.